In this video we've got two radicals that are being multiplied by each other, but we can't multiply them right away because they have two different indexes or indices. There's an index of 5 here and then there's an index of 4 here. So we need to change the way these two terms look first before we actually do the multiplication. So I'm going to do that by swinging the 5 around. It becomes the denominator of the 4, so that looks like x to the 4 divided by 5th power. And then we do the same thing with that 4, and we get x to the 3 divided by 4th power. And now we have to multiply these two variables together, and then whenever we multiply variables together you have to actually add the exponents. So if we're going to add the exponents, we're going to do that over here. It's going to be 4 over 5 plus 3 over 4. Now we have to think of two common multiples of 5 and 4 because we can't add these together as is because they have different denominators. So the common multiple between 5 and 4 is going to be 20. So I'm going to make that, I'm going to put that down there. And then 5 times what gives us 20? And that will be 4. So I actually multiply this top by 4. So it's going to be 4 times 4, which is 16. And then if you want to write this out to be mathematically correct, 4 over 4 is just 1, so it doesn't change the value at all of 4/5. It just changes the way it looks. 16 over 20 is the same as 4/5. I'm going to do the same thing with the 3/4 over there. Okay, I want a 20 in the denominator. So 4 times what gives us 20, and that's going to be 5. So we want to multiply the top part by 5, which means we multiply the bottom part by 5. So 3 times 5 is 15, and then we're adding these together. Now we could add together the numerators. So 16 plus 15 is going to give us 31, and that's over 20. So I'm going to put that over here. It's going to be x to the 31st over 20. Now because this was given to us in radical form, I'm going to put our answer into radical form. So I have x, and then this 20 becomes the index. So it's going to be still the 20th root of x to the, and that's going to be 31 right there. Now can I simplify this at all? I mean, you could leave it like this if you'd like, but you could also simplify this just a little bit. So does 20 go into 31 at all? Does it divide evenly into it? And it doesn't, but if you take out 11, then it can. So if you switch this to x to the 20th power, and we're going to take the 20th root of that, and then if we multiply that by the 20th root of 11, these two parts multiply together give us this. This cancels out because, well, the 20s cancel out because if you swing that back around over here, we're going to get x to the 20th over 20th, which is just x. And then does 20 divide evenly into 11? No, so I'm just going to keep this written the way it is, and I'm going to bring it down here. So I have x times the 20th root, I'll write that out, the 20th root of x to the 11th power, and this is going to be the final answer. And actually you could have from this point right here come to a final answer a little bit differently. So say if you took this x to the 31st over 20th power, I'm going to do that over here. You'll realize that 20 goes into 31 at least one time. So if I rewrite this by saying x to the 20th divided by 20 times x to the it's going to be 11 over 20, multiplying these two together will still give me 31/20ths. So I could simplify this. 20 over 20 is just 1, so I'll write that as x to the first. And then if I rewrite this in radical form, because our original question was given in radical form up here, this is the index, that 20. So we're going to do the 20th root of x to the 11th power. This is the power of, or well, the exponent of x. So you'll see that this is the same answer as this, and you can do it either way you'd like. It just depends on which way you feel more comfortable with.